Hi, welcome to this episode of Nerd Bar Physics. In this episode, we're going to be talking about vectors. In our daily activities, we encounter and use vector quantities unknowingly. For example, if someone asks you for directions to somewhere, you'd normally refer to a compass direction and the distance that's involved. In such a situation, you might use one or more vectors to give directions to a specific location. Generally, our description in this case will involve the use of some coordinate system, or we'll refer to some points such as buildings or landmarks. In physics, we normally use some kind of coordinate system to locate objects in the xy plane. If we refer to the intersection of the xy coordinates, that's the origin, as a point of reference, then we can draw a straight line path and it leads to a point of interest. But before we jump right into vectors and how we calculate what they are, let's learn some basic tools on triangles. To be specific, right-angled triangles. A triangle is said to be right-angled if one of its angles is 90 degrees. These triangles are special because we can use very special ratios to calculate each of their sides and their angles. We must familiarize ourselves with what a right angle triangle is and what each of its sides are called. If you pick an angle and call it theta, the side that's going to be opposite to this angle is going to be called the opposite. The side that's opposite to the right angle of the triangle is called the hypotenuse, and it's the longest side of the triangle. And the other side, the remaining side, is called the adjacent. It's adjacent because it's right next to the angle that you have picked. To remember how to calculate them, we will use a very simple phrase that you must memorize. SOHCAHTOA. So stands for sine theta is equals to opposite over hypotenuse. Ka is cos theta is equals to adjacent over hypotenuse. Toa is tan theta is equals to opposite over adjacent. So if you have a vector r, you could split it into two parts, the x and the y, giving you a right angle triangle. And from this, you will see that sine theta, in this particular case, with theta being on this side of the triangle, sine theta is equals to y over r, and cos theta is equals to x over r. If you cross multiply these two equations respectively, you have y is equals to r sine theta and x is equals to r cos theta. An emphasis on the angle theta. It's not always that the angle is going to be in one position. The angle is determines the sides of this triangle. The hypotenuse is always the same. It's always opposite the right angle triangle. But if you change your theta to be in the top corner of this triangle, then it becomes something like this. Your opposite is opposite the angle, and your adjacent is adjacent to it. In this case, sine theta is equals to x over r, and cos theta is equals to y over r. Another important tool you must remember is the Pythagoras theorem, or the Pythagorean theorem, which states that two sides of one triangle, the two sides that aren't the hypotenuse, when squared and added, are equals to the square of the hypotenuse, or a squared plus b squared is equals to c squared, where c squared is the hypotenuse. Similarly, if you have a vector r with y and x components, you will have that x squared plus y squared is equals to r squared. Also take note that tan theta is equals to the opposite over the adjacent, which in this case is equals to y over x, and in this case is equals to x over y. Another important tool that you need to know is your compass, where your north, east, west, and south are located. How far from which line in terms of degrees a vector is. Once you have all this figured out, you have everything you need to calculate vectors, and everything will be a lot easier for you. This is a fundamental part of your course, as vectors will keep popping up in almost every topic. So it's fundamental that you understand these things. Practice them, find questions on them, and do them. If you enjoyed this video, give it a thumbs up and share with your friends and colleagues, and comment down below what more you would like to see. Thank you.